and let's get started. Well, thanks everyone for coming. This has been sort of an experience with a radical openness of a dissertation, and I'm really excited to see so many people here to support and hopefully have some great questions. I'm really looking forward to talking to you today about the motivation, design, and evaluation of something called purpose-first programming. I'd like to thank my committee for supporting me. I'd like to thank Mark Gusdile from Computer Science. Barbara Erickson is from the School of Information. Stephanie Teasley is also from the School of Information. And Chris Quintana is from the School of Education. So I work in computing education. And in computing education, especially at the college level, we really care about helping students reach their goals. Now, the prototypical goal for the students that we often teach is for them to become a software engineer, and our teaching approaches often reflect that. So typically we're training engineers who are expected to understand the nuts and bolts of the medium they work in, which is a programming language. But what about learners who want to do some of the other rapidly growing jobs related to technology? So what if you want to be a scientist, maybe a computational biologist? You're writing code, but the goal is to gain insight into biology, not to build software. So for you, code is just a means to an end. What if you're someone who wants to work with programmers, but doesn't really program yourself? Maybe like a manager or a designer. You don't actually write code much in your day-to-day work, but you do need to talk about how code can be used to create the design you envision or the product you have in mind. You need to know whether things are possible. So these different groups of learners care about some pretty different tasks related to programming, but most programming instruction is designed for future software developers. So in this thesis, I'm really asking, can we design new ways to learn programming that consider a wider variety of learners' goals? So let's look at some of the things that exist now. So here's one example of a recent theory of programming instruction, and let's look at what sort of sequence is often suggested. So let me help make a little bit more sense of this by summarizing. So in this theory, it's suggested, and a lot of these theories are very linear, that you should only move on to the next skill once you are proficient at the skill before. So you notice that the first two skills in this hierarchy involve something called code tracing. So what is code tracing? So code tracing is simulating a program's execution. So it's thinking through line by line and variable by variable to understand how each value is stored in memory, how it updates. It's close and detailed work that requires an in-depth understanding of a programming language's syntax and semantics. Sometimes students will think through code tracing in their head. Sometimes they'll learn about code tracing by using a tool like a Python tutor pictured here that sort of illustrates the way that variables are created and changed in memory. Tracing activities often involve problems like the ones shown here. Now, these are problems that are typically lacking a context and don't really have a real purpose. I mean, well, the purpose is to teach you about syntax and semantics. In fact, sometimes they're even a little bit more devious than that. A lot of times they look like they do one thing, but actually do something different to force you to really dig into the details of how code is executing. So this isn't code that runs a biology experiment, animates a website, or does anything applicable in the world. These are problems about X's and Y values. So what if you are that manager or that scientist that I talked about earlier who wants to use code for a particular purpose? You want to do something with code. How does this pathway work for you? So you want to get to the later skills in this hierarchy. You want to write code that achieves a real goal. You want to describe what code does. But to get there, you have to kind of slog through some code tracing in order to reach those more meaningful pieces of code. So in this thesis, I'm proposing an alternative way to learn about code that really prioritizes code's purpose and makes it possible for you to work with meaningful code more quickly. So people like that manager, like a scientist, a data scientist, can really dig into the things they care about more quickly in their hierarchy. Okay, so to quickly summarize some of the key contributions of my thesis, I've analyzed some existing programming skills hierarchies, like the one I described as one example. I've understood both the cognitive and affective reasons why some learners avoid code tracing. I've also designed a new approach called purpose-first programming, which scaffolds code understanding in larger and more meaningful pieces. So you can think about larger pieces of code that do something instead of the line-by-line execution of code tracing. So I implemented this approach with a proof of concept curriculum, and I evaluated how novices use it and how they're motivated by this approach. Okay, so first let's talk about why some novice programmers of various backgrounds decide not to actually trace code. So the way that I understand novice programmers' code tracing is using something called their sketches. So this is the things that they draw on paper as they're solving problems. Sometimes they sketch a full trace, sometimes they'll sketch other calculations. But what's really cool is that you have this concrete trail of the things that they've done and some of the things that they've thought about. So I sort of started on this journey by finding a little bit of an oddity. So in my first paper, I replicated prior results that show that when learners write out a code trace on paper, typically that's associated with a better score on certain types of problems. But it wasn't always the case. Um, Sometimes I found that there was a certain group that started to trace their code and then kind of stopped in the middle. And these people did so poorly. They did even worse than those people that didn't sketch or draw anything at all. So I wanted to know more about not just what this traces looked like, but what are people thinking and why are they motivated to make the choices that they do? So what I did is I did a similar study, but then I went back and talked to people about the choices that they made when they sketched traces. So I used an approach called a retrospective artifact walkthrough. I used the sketches from their recent exam, along with some other aids like the problems from the exam. And I asked these learners, why did you make choices about sketching and tracing on these different problems? Why did you start this and stop in the middle? Why did you choose not to do anything on that particular problem? And I found something interesting that wasn't really evident in the sketches themselves. What I found is that novices were consciously searching for goals and patterns in code. So before they started tracing, they were often looking for something real that the code did. Does the code compute an average? Does it find the largest thing in an array? They were looking for this type of goal so they could use that to solve the problem instead of the onerous task of code tracing. Now, these are problems where you didn't necessarily need to do that. You could just go line by line and get the result. But novice programmers thought that this was better than the difficult process of tracing code. When they weren't able to identify an overall goal or they didn't really see a pattern as they started tracing, they would trace all the way through. If they saw a pattern as they go, then they might stop in the middle. Okay, so what did I take away from this first study? It seems that thinking with the goals and patterns is easier in a way because tracing has this high cognitive load. It's time consuming, it can be difficult, even for students in the 4 majors programming course that I was studying here. So they do prefer to think with these higher level strategies rather than using the detailed code tracing, but they're not always successful. It seems like these novices might need some support in order to identify goals and patterns correctly. Okay, so next I wanted to dig into tracing a bit more and understand how tracing might be helpful as a support for other tasks. Like if you want to describe what code does, how might tracing help you? So to study this, I had participants do several types of code tracing exercises, but something happened that I didn't expect. I was focused on the cognition of tracing, but participants often had some, frankly, unsolicited feedback about the value of the code tracing tasks. So almost all the participants had something to say about the activity of code tracing. It seems like sometimes they were judging themselves, they were connecting their self-beliefs to their choice to trace or not. And in fact, two participants actually refused to continue with the code tracing task. So in this paper, I went in depth to understand the reasons why these two participants decided to reject code tracing as an activity. To understand these choices, I used something called the Eccles expectancy value model of achievement choice. So this model helps us understand why people are motivated to do something. And I focus on the final four aspects of this model. So this model says that there are two factors that motivate you to complete a task: your expectation of success on that task and your value for the task. Now, both your expectation of success and your value for the task are motivated by your goals, self-beliefs, and motivations for the future. Okay, so let's dig into the first case study. This is an undergraduate in the information major, not a computer science major. He had, and both these participants had low expectancy of success for code tracing and a low value for code tracing. In Charles's case, he didn't think he could do well on code tracing problems because he just felt he wasn't able to keep all the details in mind, no matter how much he tried. He also questioned the value of the tracing task. Isn't the computer the thing that should execute code, not me? He didn't really see why he should do this task. He summarized his beliefs by saying, I'm not a computer, and I don't really want to think like the computer, but I do want to work with the computer to create code. In my second case study, I looked at Luke, who's a graduate student in the School of Information, and he described his reasoning for avoiding code tracing a little bit differently. He still had low expectation of success and low value for the task. He sort of described this almost conscious process of not really caring to remember the details of how code works. He felt like these details were not really important. And that's because he felt that the only point of this in-depth analysis of how code was executing was really just to learn the language. And he didn't really care about learning the language. That's because he described himself as not a programmer. Even though he actually does write programs to achieve his research goals, he doesn't believe that he's a programmer. He feels that code is more something that is a means to an end, just a way to create the things that he cares about. So the details of the language actually aren't important to him. Okay, so what do we take away from this study? So it is possible to connect self-beliefs to reasons not to trace code. And you can see that these beliefs can affect both the expectancy of success and the value for the task. So the learners with these beliefs that I profiled, they valued the creation of code more than a deep understanding of how code works. So this suggests that these novices perhaps could benefit from an alternative pathway to build their expertise in programming. And that's one that maybe doesn't prioritize code tracing, but instead prioritizes other activities that are more related to an authentic application context, where they can see the purpose of really what code is doing. So I decided to design to meet this need. How can we help novices create and understand complex code quickly while preparing them for future learning and emphasizing the purpose of what code does? So I propose an approach called purpose-first programming. In this approach, we use a structure called programming plans. So what that is a chunk of code that achieves a meaningful goal. Now, these plans are drawn from a particular domain of interest. So in contrast to some of the prior work on plans, which has plans that maybe are a sentinel loop or check if you're dividing by 0, these plans are really related to the domain. So in the domain of web scraping, you would have a plan perhaps that gets all of the tags of a certain type. So we can use those plans and those structures to really scaffold or support learners' understanding, writing, and debugging of code. So let me talk a little bit more about how that might happen. So typically, students look at raw code like this. But in purpose-first programming, we would add some annotations and some supports to help make understanding this complex code easier right away. So we group code as part of a plan. And each of these plans is associated with a goal that's meaningful and tells you what that chunk of code does. Now, in addition, we add sub-goals to each plan's code. And the idea behind these sub-goals is to help you have a better understanding of what's happening within each plan. Sub-goal labels have been shown to help students understand code in many different studies, so I wanted to bring them in here. We also highlight which parts of a plan can be changed, and we call those the slots. And this helps learners focus on what parts they need to change or understand, and which parts they can leave alone and stay the same. And finally, we describe how these slots should be filled. And we do that with domain-specific concepts. So for instance, in the domain of web scraping, we would talk about how you need to put in a part of a URL to this slot. We don't talk about how you need a string. So this sort of approach suggests a different way to interact with code. So instead of writing code by typing things in character by character, you're choosing plans, you're ordering them, and then you're tailoring them to meet your specific goals. You're also understanding code not by tracing through variable by variable, but you could read the goals and subgoals to understand what's going on. For debugging, you can focus on plan slots and how they should be filled instead of the entire piece of code. So this approach seems plausible, seems like it could decrease complexity for some of those learners that I talked about. But I wanted to sort of do a little bit of a test run with some of the learners and see the responses that they gave. So what I found is that preferences for learning tasks do differ between different types of programming learners. So specifically, I want to call out the differences between a group called conversational programmers and other novice programmers. So who are conversational programmers? So a lot of times we think about different types of programmers maybe along a spectrum of having more programming knowledge and use of programming in their work. So software developers are on the high end, people that don't program at all are on the low end, and you might have this group called end user programmers, maybe like the scientists that I mentioned, who use code to achieve a goal, maybe don't program all the time. So conversational programmers are sort of this more newly defined group that are sort of between non-programmers and end user programmers. The thing to know about them is that they don't really program much themselves, but they do talk about code. They want to have some fluency with code, even if they're not coding themselves. And that's so they can talk to programmers in their work, perhaps in their role as a manager or a designer. Okay, so let me highlight a couple of the differences in preferences between conversational programmers and other novice programmers. So I did a series of focus groups and followed up with a survey of students in a non-major introductory programming course. And I provided some sort of early drafts of the purpose-first programming activities to see what sort of responses I would get. So here's one result that I think shows some of the differences. So I asked the novices to rank these 3 activities as far as their usefulness in preparing you for the future. And you can see that we have on the left a really highly scaffolded code writing activity where learners just need to fill in the blank to complete code. We have a medium scaffolding activity where learners have some sort of sub-goal comments that they sort of guides their code writing. And then finally, we have an approach where there's no scaffolding at all. Learners need to write code from scratch. So what do you think? Which type of activity do you think these learners thought would prepare them best for the future? So actually, for both conversational programmers and other types of novices who plan to program more in their future, they both thought that the approach with sort of medium scaffolding was their first choice. This made sense. It was commonly used in the course as well. But where you see the difference is in the second choice, and it's pretty stark. So for novices that wanted to program more in their future, they chose the no scaffolding approach much more often than the highly scaffolded approach. For the conversational programmers, they really felt that the high scaffolding approach was a better fit for their needs. So I think what this tells us is that conversational programmers prefer more assistance from learning to code, whereas other types of novices really want to have that opportunity to learn to write code on their own without as much assistance. Okay, so let's talk about how I developed this proof of concept purpose-first programming curriculum and put the theory into practice. So I'll take you through a few steps here. First, I chose a domain. I chose web scraping with Beautiful Soup because I found that a wide variety of students in my target population found it valuable. I also chose this domain because in practice with web scraping, a lot of times a few common patterns are repeated over and over again. So it really lends itself to this plan-based approach. At the same time, though, when you're doing web scraping, you have to use some complex libraries that involve sort of more advanced concepts like custom objects, looping and collecting objects into like a list. But when you think about it in terms of the plans, you can do a lot with just a few patterns. So I went through a process of identifying authentic plans, not just ones that I created myself, but ones that were inspired by the work of other programmers in the world. So the way that I did that is I scraped files from GitHub that used Beautiful Soup for web scraping. I used a subset of those files to identify 5 common patterns. Then I annotated those patterns with the goals, the sub-goals, and the slots that I mentioned earlier. And finally, these plans were reviewed by 2 experts who use Beautiful Soup professionally. The experts found that these plans were capable of achieving realistic goals in the domain. They did suggest some updated libraries, which I changed in the plans. Okay, so I started to build my curriculum at this point. And so the first half of the curriculum involves the instructional content. So I used a worked examples plus practice approach. And the examples that I used were drawn from real websites and at least somewhat realistic tasks, like finding all the locations from a popular local pizza restaurant. Participants could run the code in these examples. So this part probably looks pretty typical. But next, I broke down the code in the example into plan pieces. So they could see that different plans made up this example. Then, by clicking on each of these plans, it takes you to a page where you learn more about that plan. So you learn relevant domain knowledge. What do you need to know to complete the slots in that plan? In this case, you need to know a little bit about HTML tags. Then there's an annotated example that really highlights the slots that you need to change in this code. There's some more information about how to tailor the code for different use cases. And finally, there are some practice activities. But instead of writing code in these practice activities, you really focus on identifying where the slots are in the code and how to edit those slots to achieve certain goals. Okay, so finally, I created some assessment activities that combined the plans in ways that were different than the combinations seen in the examples, and where learners could do some code writing, debugging, and explanation, but in a really supported, scaffolded way. So in these activities, learners benefited from some highlighting of code that really showed where the code structures were, where the slots were. In the writing code, it actually is staged so that learners can order and then tailor those plans. So first, they choose plan goals and order them in the correct way. They choose the plans that they need. Secondly, they do a similar task, but they use the code of the plans rather than the goals. And then finally, they fill in the slots of the code that they just assembled. So they really are arranging and tailoring those plans. Okay, so now that we understand what my proof of concept looks like, let's talk about how I evaluated it. There's two key research questions here. I wanted to understand whether novice programmers can really complete the reading, writing, and debugging problems with the scaffolding that was provided by purpose-first programming. Can these learners go from really zero experience with Beautiful Soup to being able to complete coding problems in the short span of this curriculum? Secondly, I wanted to understand whether this approach was motivating for learners, particularly those who were likely to reject code tracing, as I showed in my earlier study. So to do this, I ran a lab study. So I recruited students from a non-majors programming course, and I recruited learners with particular attributes. So these were learners who didn't have any prior Beautiful Soup experience, who didn't have any advanced programming experience. They had at most an introductory course prior. They had interest in web scraping, and also to address that issue of code tracing, they had a lower expectancy of success on code tracing activities or a lower value for code tracing based on responses in a survey. So for each of those 9 participants, I hopped on a 90-minute video call with them. And during that time, they went through the curriculum. First, they completed the instructional portion with worked examples plus practice. Then they attempted those novel problems, the writing, debugging, and code explanation problems that combine plans in new ways. While they did this, they performed a think aloud. And then finally, after the curriculum was done, I performed an interview that focused on their expectancy of success in the curriculum and their value for this type of task. Okay, so how about my research questions? I found that participants could complete those scaffolded problems. So after, on average, only about 30 minutes of instructional time in the first portion of the curriculum, participants were largely successful in the problems, in the assessment problems later. So recall these are participants that started with no experience writing web scraping code of Beautiful Soup. And in fact, the majority are conversational programmers who didn't plan to program in their future. I should note that of my participants, the majority were conversational programmers who didn't plan to program extensively in their future career. Okay, so in the activities where they were ordering the plans, things are relatively straightforward, although it did take more than one attempt at times. The debugging activity where learners needed to identify a bug in the code also seemed to go well for most participants. And all these activities took a shorter amount of time. Things got more challenging when learners were filling in plan slots. This was a challenging activity. There were 5 different plan slots that learners needed to fill. And so it makes sense that it took a significant amount of time. And finally, the code explanation problem was the most challenging, but this really was a problem that was involved actually 5 different plans. So learners were seeing a new combination because prior examples had only used 3 plans. So I was excited to see that more than half the participants were able to describe what this code did in English after such a short period of instructional time. Okay, So next I want to dig in a little bit more into the way that these novices were solving problems. So let's look at one excerpt of a participant's Think Aloud, where she was choosing between three different plans in the plan ordering activity. So she says, okay, first we want to start with getting tags from the soup. You'll notice that she's actually using the language that is in the subgoal labels. And she continues doing that. She reads the first subgoal label. She says, oh, okay, we want to get the first tag of a certain type from the soup. Or do we want to get all tags of a certain type from the soup? Or do we want to get the first tag of a certain type from the soup? She reflected and thought, I think it's this one because we want all of the tags of a certain type. So what's interesting here is she's not actually working with the code itself to make this choice. Instead, she's working with the subgoal labels to reason about how to build her program. And I think this shows that she's able to focus on parts of the code that are a little bit more purpose-oriented. Okay, so here's another example, another excerpt of a Think Aloud. This is from participant 9 as she's filling in plan slots in the final code writing activity. So in the first slot, she talks about how, oh, okay, that's the part of the URL that doesn't really change. She says, oh, okay, this is where I need the div tag that I saw earlier. She says, oh, okay, this would be text. I'm trying to find a comment. I'm not trying to find a link. For this part, she says, oh, okay, I just put info variable because, oh no, actually it's multiple tags. So I need to use collect info. So what's interesting here is that she's actually using a lot of domain-specific language as she's making this choice about how to write code. She's talking about tags, she's talking about links, she's talking about the idea that she needs to scrape multiple tags. And she's not using language like, okay, I need this loop, I need this string, I need to create this object. She's speaking in the language of the domain, and I think getting a little bit closer to the purpose of the code she's creating. Okay, so what about my second research question? Are learners motivated by this approach? Well, when I asked them if they wanted to learn in this way in the future, they actually all told me that they would. So to understand this motivation for this type of approach, I used some thematic analysis. So let me tell you about some of let me tell you about the themes that I identified. So learners really perceive this approach as having a low cognitive load, especially compared to some other approaches. They described purpose-first programming as helping them focus on fewer things when they were completing tasks, and also helping them apply knowledge. Participants actually felt success, and a little bit to my surprise, even some enjoyment as they were completing this curriculum. But this really seemed to be fueled by understanding and completing problems. They had a sense that they were able to understand what was going on and successfully complete tasks, and that seemed to cause a sense of success and even enjoyment. So participants did feel that this type of approach was really for beginners and also people who needed a little bit of extra help, maybe people who struggled. Now, in many cases, this described the participants themselves. They felt that purpose-based programming was a good fit for them. But they felt that it really wasn't a good fit for those really smart, more advanced programmers who already knew what they were doing. The participants believed that this type of approach gave them some conceptual and high-level knowledge, but not really a detailed knowledge of code. And finally, participants found the content realistic and applicable. They really liked that it used real websites. They could see that the code really ran. But interestingly, none of them mentioned the fact that the plans were drawn from the work of real programmers as a reason that they found the content realistic, even though this was mentioned to them at the beginning of the experiment. So I wanted to mention a little bit about some participants' view on code tracing visualizations like Python Tutor. So for some of the conversational programmers that I interviewed, their experience with these tools kind of echoed the experience of Luke and Charles from my second study in the case studies that I profiled earlier. So these conversational programmers felt that these tracing visualization tools were complex and confusing, and actually didn't really like using them. However, they contrasted that with the purpose first approach. They felt that plans were a more accessible way to work with and understand how to apply code. They really saw how it could work right away. However, not everybody agreed with that perspective. Other novice programmers thought that these type of visualizations were helpful for gaining deeper knowledge beyond what they got with programming plans. They felt that it could further their learning. Okay, so let me map the themes that I identified onto the Eccles expectancy value framework to really understand how these novices were motivated by purpose-first programming. So first, let's talk about conversational programmers, those people that want to talk about code, but not necessarily code themselves. I think there's a lot of wins here. There's a lot of things that line up for why this approach can fit for conversational programmers. So conversational programmers, both in my sample and in prior research, often have a low self-efficacy. They don't see themselves as being really good at programming. So this kind of aligns with the belief that this type of approach is really for people who struggle a little bit more. They see the approach as a fit for them. Conversational programmers also just want the basics of understanding code so that they can understand how code is applied, but they don't necessarily want all the details. So again, this type of approach really seems to fit that need. There's also the interest and enjoyment value, and also the expectation of success that came from the fact that this approach was maybe a little bit easier to start with, and that participants felt they could understand and complete tasks. So you can see why conversational programmers are motivated with purpose-first programming. So let's contrast that to other novice programmers. So these are people who want to program in their career, but they're still beginners in this particular topic area. So I think you still see some wins, the expectancy of success, the interest and enjoyment value, but there is a little bit of maybe less of a synergy here. So they want to be able to write code on their own, but the purpose-first approach is perceived as helping them learn sort of general knowledge, but maybe not all of the detailed knowledge that they would need to write code in the future. Okay, so what are my conclusions here? So in the formative study, I found that based on learners' goals, they value different programming learning tasks differently. There's a difference in the types of tasks that these learners value and want to complete. For purpose-first programming specifically, I found that it does meet many of the learning needs of conversational programmers, and they are motivated by this approach. I think other types of programmers also seem to be motivated by this approach, but it might be more of a starting place. They might need that scaffolding to fade so that they can write code on their own to achieve all of their goals. And finally, sort of more of a meta point, with purpose-first programming, we're changing the way that learners really think about code. They're thinking about code differently with the use of the extra structures that we've provided. And so this change in cognition does seem to be related to increasing their motivation for a programming learning task. So you can see how that cognition and motivation can go hand in hand. Okay, so where do we go from here? So I want to explore how purpose-first programming could possibly increase self-efficacy. I was impressed by how learners felt a sense of success after this activity, which really was a change of pace for some, especially the conversational programmers who really had a sense of low self-efficacy. So could a purpose-first programming module provide a sort of mastery experience that we know can increase self-efficacy? If so, this could have a lot of effects because we know that high self-efficacy predicts a lot of success in programming. So in this first proof of concept study, I really focused on learners' motivation, but I think there's a lot of questions of learning that would be next to tackle. So I think that it's plausible that this approach really can be a foundation for future learning. Students are seeing a lot of relevant examples. Their attention is being drawn to some of the most important elements of those examples, but the impact of this and how it fits into a learning trajectory do need to be studied further. Also, the technical supports that are needed to make purpose-first programming work could work more efficiently. So in this case, I built on an existing platform. But I think if I was able to develop a platform with a few more custom tools, it could work more efficiently. And learners could be able to write and understand code in a purpose-first way much more quickly. So for example, instead of writing code across 3 separate stages, perhaps the ordering and tailoring of plans could be combined into one single editor. It's also important to think about how those scaffolds could fade. If we're able to figure out a way to make those scaffolds fade effectively, then the purpose-first approach could reach a wider variety of learners. Okay, and then finally, there's sort of perhaps a vision that purpose-first programming could fit in a lot of different contexts. Maybe you're a computational biologist who just wants to learn a little bit about how to program a particular type of analysis. Maybe you go in, grab a few plans, and figure out how to do it. Maybe you're in a different domain, and you could do a purpose-first module that works for you. If there was a platform that could easily support the creation of this type of purpose-first programming module, this could allow the approach to reach a wider variety of users and domain areas. And so these are some of the tasks that I'd like to work on in my postdoc. Okay, so that's it. Thank you for your attention.
So hard to give you the rounds of applause for this.
That's so quiet.
Thank you, Katie. That was great. Let's see. How about if we go Chris as cognate first, and then Stephanie, and then Barb, since it's easiest for me to get her to ask her questions.
Okay, let me look through. I was jotting a bunch of things down. Great job, Katie, both on the presentation and the dissertation. This was a terrific dissertation to read. So I might just have random things throughout the defense here. One of the things that struck me then as I was looking at just how you're kind of your whole approach here and trying to scaffold, you're really restructuring the programming task, which is, you know, at writ large, kind of the scaffolding approach here. And as when people are putting their programs together, do they ever not work quite right? Like what is the notion of figuring out or debugging in this context? As you, well, I didn't quite get this right, so now how do they think about finding the bug?
Yeah, actually, okay, let me see if I have. So okay, so maybe one of the ways to think about this would be to think about sort of the deep dive. This doesn't have all of the quotes here. This sort of focuses on the domain knowledge and also has some funky animations. So I think as learners were editing the slots to complete their code, this was an opportunity where this was a chance when there were a lot of errors that took place, both I think logical errors and sort of syntax errors and problems. And so I think you saw kind of a few different things happening. There was sort of putting the wrong thing in the wrong slot. So maybe you knew that this was a thing you should use, but you put it in the wrong place. So understanding sort of like which thing goes in which slot was maybe the first hurdle. And so you see that a lot in these participants' talk, which I think is more of what's highlighted here. Okay, I know that like this thing goes here. I know that I need to look at this thing in the problem statement and apply it here. But then there was kind of another stage that was a little bit more focused on kind of still some of those lower level details, frankly. For instance, one error, someone forgot an underscore. So there were 2 underscores in the name of the tag, but they only put 1. Or maybe they forgot, I guess underscores are really a problem here. They forgot an underscore in one of the sort of next to the word class. So there's also kind of looking for the sort of details of how things are formatted just within that slot. So that's another opportunity for error. So it seems like the debugging process is sort of more of like a pattern matching situation. So you're saying, okay, this is what I wrote. Does this kind of match the other patterns that I've seen? And participants were able to use that approach effectively to actually recover from errors a lot of the time. Let's see if I have it here. This is a little bit messy here. But you can sort of see that after running code resulting in an error, participants were able to sometimes visit code pages or just edit their code and recover from that error. And so when they visited the instructional content, they were sort of looking for relevant structures that look similar to what they were working on in order to use those structures to change what they were doing.
Okay.
Okay. Anyway, it's a bit of a long answer there.
No, I think that helps. And I guess if there's a case where, you might think, okay, here's what I want to get done, and you might plan it out, and then it turns out, oh, that wasn't quite what I thought. I have to restructure. But in that case, it might be just restructuring the plans themselves, maybe at a higher level. So there could be like higher level things to fix, and then you got to sometimes dive deeply, a little more deeper.
You're absolutely right. And I think I was focusing on that last stage because that's where I saw a lot of errors in my curriculum. But I think that that's sort of an effect of the staged process. So because of sort of the limitations of the platform, they had to do these in separate stages. So first they would order the plan goals and they had to get that correct before they could move on. And I think another interesting source of error is sort of putting the plans in the wrong order, which did happen. And so I think that it was interesting because the participants were able to recover from that fairly quickly, but that was absolutely another source of error.
Okay. In terms of, so like, in a teaching context, I could see, you might have a domain that's a little more scaled down, or if it's a larger domain, maybe we're going to start out with some problems that are, some subset of plans from that domain. Might there be a problem if you're trying to use this in a domain? How might you handle a situation where maybe there's a really large number of plans? Is there like a point where there's too many plans to sort of, I was kind of thinking of it like with object-oriented programming, the hope was, oh, we'll have all these objects and then libraries of objects, and then you just go find the objects you need. And then it turned out a lot of these libraries, it was really hard to find the objects you need. So, I guess where do you see the from a teaching standpoint, where do you see, okay, we maybe need to limit it to this amount of plans as we're starting out?
Yeah. So I think that I had some practical experience with that as I designed this proof of concept curriculum. I sort of set myself a bit of a hard limit at 90 minutes for the video call because I figured, with Zoom fatigue, that was kind of what I needed to do. And I guess that kind of also fits maybe like the longest course period in a typical programming course at the college level. And what I found is I actually started with too many plans in my first draft. I started with a larger number of plans. I think it was around maybe 8 plans. And I realized that this was it was too many to do in about an hour of time. So when I cut the number of plans, when I combined a few of the plans into larger plans and cut the number of plans to 5, it fit the timing just about perfectly. I think it's also the plans, but also like the number of combinations you have. Probably also impacts it. I guess, just anecdotally, I do feel like 5 was a pretty reasonable number, but you do have to choose a certain number that can do reasonable things with just 5 plans. plans. So that is a design constraint for sure.
Yeah,
Um,
but I could see, from a teaching standpoint, you'd start out small and then just build it up and build it up as
yeah,
students gain more experience. And I guess it's the difference is between using this approach as a teaching tool versus just as a more general purpose programming tool for people who aren't necessarily programmers, right? And that could be that's kind of the trade-off to think about.
yeah, and I think on the Hacker News post, I saw some feedback from programmers who were sort of saying, there's always this new layer of abstraction, but for the law of leaky abstractions, it's you always have to go down to the lower level details. So why do we even care about all these abstractions? But I think in a learning context, it's a little
Sure.
different, especially for these particular learners who really have different endpoints and goals. And
Yeah.
I'm not saying that people should use this approach all of the time. I mean, maybe maybe conversational programmers could rely heavily on this, but this is sort of a starting place that could lead to other things. So I don't think you have to get everything in there in the first brush.
Sure. Yeah, I'm not sure the audience. I'm not sure Hacker News is the target audience, so I think that's a good.
The response actually was surprisingly positive. I think because it wasn't a super popular post, I think that might have helped.
Yeah.
I think there is kind of this idea that we should emphasize purpose more, which I mean, it was nice to see that anecdotal feedback a little bit.
I guess building off of that, then one other thing that struck me, and I think it was slide 57, the persona you were talking about in that slide, who maybe as they're starting this, it's the person who wants to start learning more about programming itself.
Mhm.
So I was just thinking about how your thoughts on how you might use this approach, but as the launch pad. And how would you then start supporting someone who does want to learn more about the code?
Yeah, yeah.
Yeah.
I think that's a really rich area for what could come next here. I think there's I think my results are really encouraging for this as kind of a starting place where you can kind of maybe build some momentum. You have this positive initial experience. You might feel successful because you're able to do things right away. And it also kind of gives you a little bit of an overview of what's possible, right? I think that was something some of the participants expressed. Oh, I didn't know you could do that. Is that how that works?
Yeah.
So you have this initial positive experience that also, from a cognitive standpoint, provides a lot of rich examples that you can draw from. So I think one of the keys would be how do you help learners take away important points from those examples that they can apply later? I think that's why I'm excited about learning more about the literature on how learners draw from examples. I think it seems from that literature, it's really important to highlight key aspects of the examples. Just providing examples isn't necessarily always enough.
Right.
So hopefully the plan approach can kind of help you notice key things in code that you're working with. You should focus here, focus there. Maybe this sort of thing tends to come first. And so hopefully that could make your experience with maybe more complex examples later a little bit easier because you're able to sort of recognize some of these patterns a little bit more readily. So yeah, I think that's one of the things you want to keep in mind. How can you kind of build on that strength of recognizing patterns? I think one idea that I sort of was considering is could you have kind of this whole spectrum? Maybe you're working with plans, but if you want to, you can sort of have all of the annotation maybe fade, or you could kind of dig into one plan specifically and maybe trace it through with a visualization tool, just that plan itself, maybe. So I think there's an opportunity to kind of go the full spectrum from here.
Yeah, well, the nice thing is you're separating out the kind of the conceptual of here's what this chunk of code does with the actual implementation. You're kind of separating out concept and implementation of that concept. And if someone just wants to focus on the conceptual, they can do that. If someone wants to dive in and learn more about the implementation, which is now learning about the code, they can do that, but you're not sort of forced into either path. I mean, it struck me reading this how it resonated with you talked about code patterns and design patterns, and it went back to the original sense of patterns from Christopher Alexander in architecture, and that was his whole point, that we're going to separate, here's the conceptual solution from the actual way we're going to implement it. And so if you wanted to learn the ins and outs of the, building a porch as the implementation, you could, but you didn't have to go down to that level. You could sort of stay at the conceptual level and see, how do I assemble all these patterns into the building I'm trying to create? And that's kind of the same sense I got with your approach here. So that was,
great.
that was cool.
Yeah, I think that's great to hear. And I think the participants sort of seem to speak to that as well. They sort of would sometimes, they would mention that this was sort of conceptual, a little bit higher level. But I think what's interesting is that it's using sort of this glass boxed approach, right? You're sort of guided to focus on certain things, but the real code is not actually obscured. So in other approaches for non-programmers, the code is oftentimes maybe even fully obscured, and you're working with sort of another layer on top of that, maybe like a block-based language. But we know that learners sometimes don't really view that as being authentic to expert practice. And so for these learners that I'm talking about, they want something that is authentic to expert practice. And so this approach, I think, lets you sort of see the expert practice, but you don't have to fully dig into it unless you want to. But if you do, it's there for you to move forward.
Yeah. Okay, great. Thanks.
Thanks.
I think I'll pass it on to Stephanie.
Cool. Thanks, Chris.
Mhm.
Stephanie.
Great, thanks. At the risk of going second, and is that maybe you're preempted by some of the prior questions. So thank you, Chris, for asking some of the things that I wanted to know. But I come at this, as you know, Katie, I come at this thesis from a very different perspective than your other three committee members, in that I don't program and I don't teach programmers. So I was really looking at it sort of at a step up. And first of all, I have to say, really very, very nice job. I was, for someone who doesn't program, it was amazingly readable and comprehensible. And I really understood what you were trying to do and why you were trying to do it. And I did see a lot of analogies between some of the things that we know about teaching other things, like reading, right? That you can learn to read before you're necessarily a good speller. Thank goodness, because I was never a good speller either. But anyway, but there were a couple of things that I was particularly curious about, and I think they have to do with this idea that there are people who come to programming already with this notion that they can't program, or that it's going to be hard for them, or they're not going to be good at it. And you say in the methods section for the last study that these were people who've had at least one class.
Yeah.
And they use language like, some of the quotes were someone like me who wants a lot of help or needs a lot of help. So, and then as a result of that, then people talked about this technique, this type of curriculum might be for those kind of people. So I'm wondering if you think that there's a risk that the use of this technique continues to reinforce that self-image rather than building confidence that you can discover that, hey, you might actually really enjoy programming and could be good at it, because after you've reduced that initial frustration level of never getting it right. So can you talk a little bit about that?
Oh yeah, what a great question. I think, I think that definitely is a risk that we should consider. At the same time, I think that getting that initial experience of being able to be good at programming and feel like you understand what's going on is probably a prerequisite to those later stages, right? Like, I think having that sense of success and confidence kind of builds on itself and can build and build until you're ready for the more advanced activities. So I can see an argument that this approach kind of helps maybe jumpstart that in a way that the more detailed code tracing or more onerous code writing activities maybe wouldn't. But then I think your question really speaks to, okay, well, what happens next? Are you kind of locked into this, more hand-holded approach, or are you going to be able to be supported to move on? And I think that's where the next step is really important, which I think is, a little bit to be determined. Um, can this scaffolding fade in a way that helps you progress to more, not just more advanced tasks, but maybe tasks that help you see yourself as a programmer?
Yes.
So I asked the participants, did you feel like a programmer when you were doing this activity? And I got some mixed responses. So some people said, yeah, I'm doing web scraping code, like I'm a programmer. Other people said, no, I'm not a programmer because I'm not writing code from scratch. So
And
writing code.
can I interrupt with the question then? You said those different types of reactions. Did they map onto your conversational versus the other two types that's more intended to be programmers?
I didn't see it map on.
Okay.
It is a little bit tough with this, smaller sample
Yeah,
size.
sure. Of course, of course.
Yeah, but I didn't see it map on. I think the theme that I feel most confident in drawing from that is that writing code from scratch is what a programmer does. And I wasn't always doing it here. There were some instances where I was, filling in the blank for this code, and I was running real code that actually ran. So that kind of was programmer-like, but writing code from scratch unassisted is, I think, the prototypical programmer activity. So if you want to help people feel like a programmer, I think you need to kind of help them maybe write more and more code unassisted.
Right. And that's
But
why I think that transparency aspect that you talk about, you're not hiding what the real code looks like. And just like the more you read and see more words and see patterns and stuff, you start to figure that stuff out. So I think that's a really good point. And I love the idea of fading it. And you having essentially a transfer task where you've taken away part of the structure and then the next time part of it, and to see how much they really can internalize what the actual details of the code look like. And then it would be interesting to see what kind of bugs arise from after they've done fading, and are those different kinds of bugs than the more traditional approach would take.
yeah.
So I really like that. Because that was my second question about that we sort of already talked about. How would you transition this to an existing curriculum? Like, can you think about, talk about, so you wanted students who already had one class, but there was one CS class, but they were novices, because I think you needed to jumpstart something, right?
Yeah.
And
Yeah.
so, but what if, could this be used in your very first experience learning to
Yeah.
program?
I think that is part of the vision. I think, just like you said, for this first proof of concept, I wanted to work with a population that had a little bit of prior experience to sort of see how it would, but a new domain area. So I think that there is sort of a potential danger in this approach of being overwhelmed by all the newness. I think for most participants, it was fine. For one of my participants, she felt like there was so much new stuff going on. There's HTML, there's code, there's Python. There's a lot happening. Maybe another side point is that some of the participants, this was the first time they were working with Python. So it was new in that regard. It was a new language for them. So, okay, could this be used as sort of your first programming experience? And would you come away from that feeling successful or feeling overwhelmed? I think that it's hard to say until we study it. I think it's plausible. You're using skills that are kind of putting things in order. You're sort of copying and pasting examples. I think one of the possible failure points is that more advanced programmers are a little bit more attuned to sort of common patterns already in the code, right? Like they're probably less likely to leave off that underscore that I mentioned because they'll have noticed, oh, there's an underscore in that variable name. And I think I saw with a couple of my participants who wanted to be like a data scientist or write code more, they seem to move much more quickly through the activity, and they seem to notice some of those details more readily. They didn't have to go back and check as much whether this matched this. So I think that's the things you really want to keep in mind. And so that might point to activities where there's really not as much variation in the slots that you need to fill in. So you have maybe fewer opportunities for those things to trip you up.
But I think there's also sorry to interrupt, but I think there's also a general orientation difference. And so as I was reading the thesis, there's a couple of quotes that you have on page 131. Don't worry, you don't have to flip and find it. And like you reference participant 5 when they're explaining to you why the plan's approach was good. And participant 5 said, I think for someone like me who wants a lot of help, who needs a lot of help to do well and wants a lot of examples, the plan worked really well. So this is someone like me. So that references their self-identity. Now, participant 7 also agreed that it supported what she wanted, but participant 7 was one of your people who intended to be a front-end programmer. But the way she put it was, I have to fail at the code 10 times before I realize what I'm doing. So I guess I sort of like this. So there, the failure was more about efficiency. I'm inefficient, not that I'm bad or I'm someone who needs a lot of help. And so, I mean, I just think that you've got some really tantalizing clues here about how we could use an approach like this and who would benefit the most from it as a really early touchstone to entering CS. And I think one of the things that could come out of it is something that I guess I suggested earlier is if you come into coding thinking you're someone who's not going to be good at it, and someone teaches you in a way that shows you that you can be good at it, then you may actually open up the possibility that you could be a front-end programmer. Maybe you decided to be a back-end person because you just thought you'd never be able to do real coding. So that's what I think is really wonderful about what you're thinking about and what you've done. So I really appreciate that.
Oh, great. That's great to hear. Thanks, Stephanie.
And so that really, that covers most of my notes, including some of the answers that you gave to Chris. So I'm happy to turn things over to Barbara next.
Great. Thank you, Stephanie. Barbara.
So just a quick one. What are some implications of this for how you would create a debugger then, or particularly for code tracing? You know, how could you code trace at a plan level?
Oh, yeah. Yeah. So I think that's a pretty cool idea. Let me, let's see, let me put up a sort of this earlier example. So I think, yeah.
You go ahead, Katie.
Yeah, I think something that's, I think, sort of key to this purpose-first approach is having this sort of annotation of goals and sub-goal labels. So this presents an opportunity to sort of trace code not variable by variable or line by line, but by using those sub-goals. So I think that the design of the sub-goals would be important to sort of enabling that type of step-by-step debugging. So I didn't mention it, but the sub-goals were designed in a way to sort of have kind of an in and out in most cases. So you're getting this thing from this thing. You're getting this thing from this thing, which I think matches a lot of the way that code typically works. So you do have some of this like sort of flow happening. So I think that what this approach might allow is that you can kind of zoom in maybe into the sub-goal that's most relevant, maybe just using the language of the sub-goal. Maybe once you're in that area, maybe you could dig in deeper. Or maybe you can just kind of stay at the sub-goal level. So for example, if you have ordered your plans correctly, the sub-goals aren't going to match up, as well as the fact that the goals aren't going to match up. If you put plan 3 above plan 2 in this case, you're getting first tag of a certain type from the soup, but you don't have a soup yet. So that could tell you that you're off in a way that doesn't involve a super deep dive into the code. So I think it is possible to scaffold that tracing just at the level of subgoals. And we did see some participants use that approach as they were solving problems, just focusing on the subgoals themselves. So I think it's definitely viable. But I think the design of the subgoals is important. And I think you want to maybe focus on a few, some of the key outputs of each sort of section, if that makes sense.
Nice.
We do have an advantage. We've seen this presentation a couple times. All right. And I'm so glad that Philip Guo left his camera on so I could see his expression as it came up. Oh, let's talk about, yeah, Mickey Mouse. Excellent. Okay. So I just have one question for you, Katie. That's it's just an implication question that I know that some of the folks on here, like I see Josh Sheldon's here. What is the implication of your work at the K through 12 level rather than the tertiary level? All right. I mean, how you were able to grab students, first of all, as Stephanie pointed out, who'd had an intro course already, so that they were already framed, but they also had a sense of where they want to go: conversational, front-end programmer, end user programmer. Do you have any ideas about what would you do if you were starting out at the high school level?
That's a great question, because I think this work really has been motivated by sort of aligning with students' goals and where they want to go, because that can be such a rich place for drawing on motivation. But for students in K-12, I mean, you know, at that stage, I mean, K-12 is large, right? Like let's talk more middle school, high school level. So you might be considering different general areas, and you're probably thinking about a few different things. You know, am I good at this? Do people tell me I'm good at this? Do my friends do this? But also like what's possible in these different domains.
Yeah.
I think there might be an opportunity for this type of approach to kind of serve as maybe a little bit of like a sampler platter for what you can use code to do. So if you had maybe like a few of these modules, let's say, that helped you quickly and easily explore how code can, I don't know, scrape websites, how code can draw stuff, how code can, I don't know, make video games for the gamers out there, how it can analyze sports data. You could do a variety of different sort of general interests, and you could allow these students to kind of get started quickly and easily, but without sort of the in-depth hassle that really doing full coding can often require. So hopefully this could maybe give a little bit more of a perspective of like, what can you do with code that's not just some of the most prototypical activities like developing software or doing video games. Maybe it could show sort of things that are possible with code, which we know can inspire a wider variety of learners, right? If you can see how code can be applied to do stuff, that does seem to be related to motivation, maybe especially for women, and might inspire them to be interested in code in the future, or at least be aware of what's possible with code, right? As they become more of a computationally literate student.
That also feeds into what I was saying earlier. We know these self-perceptions and images of what I'm good at and not good at start pretty early, certainly well before you get to college. And in fact, you would sort of be curious whether the School of Information students are picking School of Information instead of computer science because their earlier experiences already led them to feel sorted into, you know, better at one thing versus another.
Yeah, I think that actually came through in the interviews. You know, there were a couple people that kind of had started with a computer science course and were sort of like, okay, I want to go to information now because I feel like that's a better fit for me. Yeah.
Other things that I see, I mean, I love your answer, Katie, but also the fact that you got folks feeling successful about Beautiful Soup with 30 minutes of instruction, and that you timed this to fit inside of 90 minutes. And you even had, I mean, you one of the quotes that you got in your last chapter that I so loved was a student saying, "Boy, could you do this for other domains for me? I'd love to have one of these every week." I mean, you're sort of the Duolingo of programming here. But that idea of that the high school class could be a smorgasbord, right? You get this, here's a buffet. Here's all of what computing could be for you. We could do this week after week. I mean, that's a really lovely model, and which you, because you fit into such a fine bit of time and yet got success in the
Yeah.
small bit of time, is really cool.
Thank you. I think there is a lot of possibility here, but this is an approach that maybe has, you know, some scalability. It doesn't necessarily scale at a really great rate, right? So to create all of those different modules would take a lot more design work. At the same time, though, that type of design work is what teachers are doing all the time, right? But I think this points to sort of maybe this design of a platform in the future that can make it easier to create these different modules more easily so that we can cover this variety of domains. Because I think the interest in the domain seems to be important for this type of experience. So having a variety of domains, I think, is probably key.
Cool. Do any other committee members want to ask Katie questions? The chat is totally full. It's 11:20 now. We could do maybe 15 minutes perhaps of questions. Does that sound good to the committee? Okay. I'm just going to go in order from the top. The first one from Philip came in approximately 20 seconds after you finished. And his question is, I'll go ahead and say it, Philip, and if I don't get it right, please feel free to unmute and chime in. Basically, how much effort is required to produce one of these purpose-first curriculum? Your background in being able to do this in web scraping and in knowing about teaching, what would it take to enable others to create purpose-first curricula?
That's a great question. And I think, you know, as an expert in this area, it might be easy for me to undersell the effort. But I do think there are opportunities to sort of streamline this process. I think that there were sort of maybe two parts that I thought were the most challenging. So I think that was identifying the plans and then identifying sort of realistic examples that used combinations of those plans. And so that was a process that took a good amount of iteration for me. So I went to a variety of different websites. I saw, okay, can I scrape something interesting from this website using just this number of plans? And I think I generated maybe 3 times as many potential examples as I actually used in the curriculum, or maybe twice as many actually. So there was a process of sort of sorting to make something that seemed realistic, but only used sort of this more limited structure. And I think that is challenging. At the same time, there's other parts that are relatively straightforward. So once you have the plans in place, the sort of practice activities just involve focusing on the slots that you're filling and editing. So once you have a little bit of information about how to do that, you could generate a really wide variety of practice examples using just the same basic structure. So I think in this case, I had sort of 2 examples that used all 5 plans. You looked at each of those plans individually, and then you recombined them in different ways in the later activities. You maybe don't have to recombine them in different ways. That could be maybe a higher bar. Maybe you could just kind of use variations on your first example. But I think if there was a sort of a process to kind of maybe more automatically generate the sort of practice activities from the plans, I think that can save a lot of effort. I guess I'll just emphasize again that like finding the plans was challenging, but at the same time, I had put a lot of stock in this idea that drawing plans from expert practice would really motivate learners. But then I found that these learners didn't really mention that fact at all. It seems that what they cared about more was the fact that the code actually worked and actually did something useful. So I'm not sure that you need to go through the onerous process of, you know, scraping some sort of expert repository and generating problems from there. You could maybe just talk to one expert, grab some common patterns, and then go from there. And I think that would decrease your workload as well. Yeah, maybe that begins to answer that question.
Philip gives us a thumbs up. All right, I want to take Nate Dubinsky's question because I think it's a wonderful follow-on to that. And I'm going to say it in ways that connect directly to the question, Nate. So if I don't quite get to the point right, please feel free to follow on. Katie, what if you had an open source community that wanted to produce purpose first curriculum? Could you imagine mechanisms that they could do in their open source process such that they highlight, oh, here's a plan, oh, and here's a plan. And then also then how could you crowdsource the effort to produce the curriculum? Have you given it? I mean, I know that's a totally new idea for me, but can you give some thoughts to what would it be like to have sort of the programmers collaborate with you to help produce the purpose first curriculum?
Oh, interesting. So it's not just maybe people who are teaching, but it's actually the programmers themselves who are contributing the plans.
If the open source curriculum could say, while we're building this, I don't know, we're working on Blender, the digital video production software. Oh, you know what? Here's 5 plans that we often use. Let's highlight these so that curricular builders could grab them.
That is so cool. And I think there are some sort of, I don't know, data mining or machine learning approaches that could kind of help with that. I think I sort of messed around with them a little bit. It seems like there are ways you can maybe get like a first brush at what sort of structures are common in a particular corpus of code. I think though those would need to be sort of annotated and modified by humans. But that is one way that could potentially sort of get you started. But I think you could find some of these common patterns a little bit more automatically, or maybe even better through the practice, like the question asks. But then I think the annotation is really important. But I think what's really cool about this idea is that you have these experts from the domain who could maybe annotate the plans themselves. So that means that the sub-goal language would also be really aligned with expert practice. Excuse me. And I think that's pretty cool, because then you're not only looking at code that works in the domain, but you're also talking about sort of language and terms that are really relevant to the domain. I think it's a great idea. I think practically, probably you'd want to work from those key examples. That was something sort of practically in my process that worked well. Once I had a sort of full program that could execute, that was made up of the plans, I knew that that was going to be past the bar to be included in the curriculum. So maybe having these kind of like small programs that do cool stuff and use those plans that are identified would probably be key to bridging the gap between just, hey, here's a plan, and here's something that could actually fit in a purpose-first programming curriculum. Yeah, so I love the idea. Let's do it. I think that would be
Let me try to put in, a lot of the questions are questions of a form that Chris and Stephanie already asked. But I like one that's in part of April's question. You've framed this as being sort of part of formal education, that you were doing the training for that, for the 30 minutes instruction and giving hints. Could you imagine purpose-first programming being part of an informal education effort? How could you, for example, leave purpose-first programming lying around? I've been making references to Duolingo. I mean, could you think about framing it in a Duolingo kind of structure?
That's really interesting. I think kind of speaks to my maybe sort of, I don't know if it's bias, my experience of sort of coming from the formal education system, from my prior job, and sort of my belief that formal education is a way to reach a really wide variety of learners. But there is so much opportunity in these sort of informal activities. And for an approach that maybe doesn't take much time, it might be a great fit for that type of environment. It seems like the community that was referenced in the last question could maybe be key to that. I could see that going a couple different ways, right? If you don't feel like you're a programmer, do you want to join this like programmer plans community? Is that a bit much? Or maybe it's about these programmers reaching out to newbies in sort of an intentional way and not as much of like a gatekeeping way. That's interesting. So how do you leave these lying around? I think is a great question. I could see sometimes there's a desire for maybe these like, I don't know the correct term, pack and play, just kind of like pre-packaged activities that could be used in an after school club perhaps, or maybe you're doing this with others. I think one advantage of sort of having a self-contained activity is that it's kind of easy to put in different places. So I could see this kind of fitting into some of the after school activities. I think you can see that I'm sort of slowly inching my way to more of the purely informal space from the formal space. But if you're just someone who's, playing around on the internet, could you find this and like work with this? I think that's an interesting question that I'm not sure about, because how do you find it if you're not really interested in programming in the first place? Or if you, I think, one idea that I had is, you're driven by your goals, right? You want to do this particular thing. So if you're driven by this particular thing, then maybe as you search for like, how do I don't know, analyze this type of data? How do I, do this? You might come across maybe like a web interface that has these are like the most common patterns you see for this type of problem solving. And this could maybe be like a starting place for the way that you address that problem. So I don't know, I think if I really want to go to like the vision, having a lot of people be enabled to create these little modules could maybe allow more opportunity for people to kind of stumble across this approach. So if you're, a computational biologist who's enabled to create this type of thing, maybe, for your very specific domain area, maybe you could quickly and easily create a little module like this that you could share with others. And then you might kind of come across this approach as you're circling around. I do think it presents kind of interesting alternative to some of the existing tutorials. And so maybe that's an approach that people could take on if it was easy to do this. Yeah, really interesting. I'm still thinking about it.
Okay. And I think this will probably be our last one. It's from Ben Wheeler from the Scratch team. And he also said later that he's stepped off. So I will have to interpret from his chat. I think he really framed it as an interesting question. Think about what you're doing, Katie, as being akin to a boot camp. I'm going to teach you to do a particular set of things quickly. Along a trajectory, at what point will you need concepts? When you're going to need lower level things about computer science. So does purposeful programming actually lengthen your learning path? Or is it about reducing barriers that would, not going any further is an infinitely long learning path. How do you see this fitting into sort of a network of possible starting points and to a network of possible ending points?
Yeah, I think the network analogy is really apt, right? Instead of this sort of single linear approach that might be favored by computing instructors. I mean, it makes sense, it's straightforward and maybe fits with a lot of our existing learners. As the number of people who want some piece of programming grows, you're going to have more starting places and more ending places. So I think that the point is well put, that if you opt out early on, your learning path is non-existent. So for these particular type of learners, starting with this activity could maybe be a way to help you engage on a longer and more fruitful learning path. So then what do you do next? Do you sort of jump between different modules? Hopefully at some point maybe hopefully is the wrong word. Maybe at some point you get inspired to dig in a little bit deeper. So how can we make that opportunity available to you? Probably the Scratch team is are great people to talk about this with the low floor and high ceiling. How can you start with this approach, but then sort of have that faded or sort of lead you into more general purpose programming tools? I think learning the syntax and semantics is really useful for more advanced code creation and understanding. I think it's a great question that probably would require a lot of intentional design. I hope that as the scaffolding sort of fades, you might realize the necessity for some of those different concepts and understanding. And I hope that once you're inspired by a particular domain of interest, the sort of need for understanding that lower level detail might become a little bit more clear. I think it's a really interesting question, and that further design is needed.
And I think this is probably a good time for the committee to excuse themselves. But everyone, let's thank Katie once again. Terrific job. Katie, you can just hang out here. We'll be back in just a few minutes.
So Mark, just to be clear, we're leaving this, going to the other one, and then we can rejoin this.
That's
Okay.
right, exactly. Yep.
Just didn't want to disappear.
Oh, wow. Now I can see everybody. I didn't want to see you all while I was
That was wise. And there's a lot of chat if you want to chat with all of them. We'll be back in just a few minutes.
I'll hang out here while the committee goes away. So y'all don't have to stay, but I'll stay.